So our aim for today is to be able to solve quadratics using the quadratic formula. So this is a formula that you will be given on your formula sheet in an exam. So it's going to look a little bit crazy, but you're not expected to remember it. So we are going to apply our previous knowledge of solving quadratics, and once we're given our formula, we're going to substitute into that formula, and our aim is to find the roots of this quadratic function that we're given. So what is the quadratic formula? So when we solve a quadratic equation, so for instance, if we had x squared subtract 3x plus 1 equals 0, previously in lessons we have seen that we would factorise this in order to find two different values of x, which would be our roots of our function. But in this case, if we were to factorise this using trinomials, there are no two numbers that we can find that multiply together to give us 1 and add together to give us -3. So we are unable to fill this in using the previous methods that we've looked at so far. So it doesn't factorise. However, it's still a function, so it still has two roots. However, once this function has been graphed, we can see the two roots, and the first root lies somewhere in between 0 and 1, and the second root lies in between 2 and 3. So there are roots, so it can be solved, but the roots are going to be decimals. So using our previous method of factorising trinomials, we wouldn't be able to find that. So we have this new strategy called the quadratic formula. So this is how we are going to solve these equations. So the quadratic formula allows you to find the roots of a quadratic equation, if they exist, even if the quadratic equation does not factorise. So like I said previously, all the questions we've looked at so far, we were able to factorise them and find our two roots. But what happens if we can't factorise them? They can still be solved, but we're going to use what's called the quadratic formula. So for the quadratic equation of the form ax squared plus bx plus c equals 0, so all the quadratic equations we've looked at so far are in this form, where we have some number for a, b and c. The roots of the quadratic equation are given by, and I'm warning you, it's a crazy looking formula like this, but once we break it down, you'll see that it is really straightforward, and we're just going to use our previous skills of substitution for us to solve this. So a few little important facts about this is this symbol here, plus and minus. We're going to see what that means when we go through an example. Another important factor of this is that it is a fraction, and everything on top of this fraction is all over 2a. Some people often have just the square root over 2a, but it's not, it's all of this top line over 2a. So as I mentioned previously, you are given this in the exam on your formula sheet, so you're not expected to remember it, so don't worry about that. So let's look at this in an example. Okay, so we are going to use the quadratic formula to find the roots of the equation correct to two decimal places. So in an exam question, or practice question, if you're asked to solve the quadratic equation, and if it says, it might not necessarily say use the quadratic formula, but it might say correct to two decimal places. If it ever says to decimal places, there's your hint that it's going to be a quadratic formula question. Okay, so we've got x squared subtract 3x plus 1 equals 0. So this is an example, so I would be expecting you to copy it into your notes jotter. So if we compare this to our standard quadratic equation, so a comes in front of your x squared, which is clearly 1, because 1s are invisible. Our b is -3, and our c is 1. So we're going to take this a, b and c and substitute it into this quadratic formula. So it's just going to be a straight substitution into this formula. Okay, so for b is equal to -3, so we need to be careful with our negatives. So b is equal to -3. And then underneath we've got plus and minus, and underneath our square root, we have b squared, so that's -3 squared. We're then going to subtract 4 times a, so a is 1, and then we're also timesing that by c, and c is also 1. And then all of this is over 2 times a, and since a is 1, it's just 2 times 1. So it's still looking a little bit crazy until we simplify it down. So this subtracting -3 just becomes a +3. We've still got this plus and minus, and underneath our square root we've got -3 squared, which is 9, subtract 4, so 9 subtract 4 is 5, and 2 times 1 is 2. You should never have, in this case, if you're asked to solve, just be careful of your negatives. When you square a negative number, it's a positive. So you would never get a negative number after squaring something. So now we've simplified it right down, we're now going to explain what this means here. So we've got a plus and a minus. If we think about our previous examples when we're finding roots, we often find 2 roots, so 2 values of x, and this formula does that as well. So the plus and the minus, we're going to split that up into 2 little equations. So our first one is 3 plus root 5 over 2, or x is equal to 3 subtract root 5 over 2. So we're just splitting this plus minus up into our 2 little mini equations. So we're going to solve for x. So what we would do at this stage is this would be a calculator paper, so you would just pop all of this straight into your calculator, making sure you're doing 3 plus root 5 first and then putting that over 2. So you get 2.618. So I suggest you just trying this to make sure you are getting that out, to make sure you're putting it into your scientific calculator correct. And then you would do the same again but with a subtract. So you want to be writing down your unrounded answer first, and then going back to your question and making sure you're rounding it to 2 decimal places, which will give you x is equal to 2.62 or x is equal to 0.38. So that is, we've solved it. We've got our 2 roots, just to show you what this would look like on a graph. So these are the roots of the equation. Remember, roots are where the graph cuts the x-axis. So here we've got our graph of x squared subtract 3x plus 1. And we've got our first root, which is 0.38, between the 0 and the 1. And our second root is between the 2 and the 3, which is 2.62. So again, if you just make sure you've got that copied into your notes jotter, and I'm going to do another example. So just pause it if you need more time to copy that down. I'm going to do another example, so I'm just going to move on now. So same again, we're going to use the quadratic formula to find the roots of this equation correct to 2 decimal places. So again, you might not be told to use the quadratic formula. You need to be aware that if you're ever asked to round it to decimal places to find roots, then that is a quadratic formula question. So here we've got 5x squared plus x subtract 3 equals 0. If we compare this to our standard equation form, we can pick out that our a is 5, our b is 1, because there's an invisible 1 there, and our c is -3. Again, being careful with those negatives. And now we've got our a, b, and c. We're just going to substitute those values into our crazy looking quadratic formula. So we have b is equal to 1, and underneath we've got plus and minus, and underneath our square root we've got b squared, so that's 1 squared, subtract 4 times a, so that's subtract 4 times 5, and times it by c, and c, remember, is -3. And then that is all over, so everything, including that -1 at the start, that's all over 2 times a, so that's 2 times 5. So in an exam question, you often get a single mark for substituting incorrectly. So just make sure you are taking your time when substituting in to make sure you're getting the correct values in the right place. So now we're going to simplify everything that's underneath this square root. So we've got 1 squared, subtract 4 times 5, which is 20, times negative 3, which is negative 60. But because we're subtracting negative 60, we're then going to add it. So it's 1 add 60 to give us 61, and then 2 times 5 to give us 10. So once we have got to this stage, we're then going to split this equation up into our two little mini equations, one with a plus and one with a subtract. So we've got negative 1 plus root 61 all over 10, or negative 1 subtract root 61 all over 10. And at this stage, this is exactly what you type into your calculator. So you want to write down your unrounded answer first, and then your second one where you've subtracted. And remember, it's okay to have a negative because this is just where it crosses the x-axis, so it can cross the x-axis at a negative number. That's totally fine. And just round it to 2 decimal places, so we've got x equals 0.68 or x equals negative 0.88, and these are the roots of the equation. And just to see what this looks like as when we draw the graph, here we've got the function 5x squared plus x subtract 3. Our two roots, x equals negative 0.88 and x equals 0.68. So again, it's good to have a second example copied into your notes drawer, so just pause this video just now if you need to do that. And on to the next slide, I am going to ask you to do this one on your own. So you're going to use the quadratic formula to find the roots of the equation correct to 2 decimal places, just as we've been doing. So if you just pause the video here and give this one a go. You have unpaused and you're now ready to hear the solution. For this one, we have to be careful because there's 2 negatives here. So once we compare this to our standard equation of a quadratic function, you should have a is equal to 4, b is equal to negative 3, and c is equal to negative 5. So we've got these 2 negatives that we're going to have to be careful with when substituting it in to our quadratic formula. So again, you're not expected to remember this formula, just beware that it is on your formula sheet, so please use your formula sheet in an exam. And we're going to substitute these values in. So our first value is b is equal to negative 3. So because we've got a subtract b, so we're subtracting a negative 3, that becomes a plus 3. We're then going to plus or minus the square root of negative 3 squared, subtract, and then you've got 4 times a, and a is equal to 4 as well, times and by c, which is negative 5, all over 2 times a, which is 2 times 4. Once we simplify that down, you have negative 3 squared is 9, subtracting 4 times negative 5 is negative 80, 2 times 4 is 8, and because we've got we're subtracting a negative number, that becomes an add, so we've got the square root of 89. So now we've got that simplified down, we're going to split that into our 2 little mini equations. So you should have 3 plus the square root of 89 over 8, or 3 subtract the square root of 89 over 8. I've just done the square root of 89 here, but you don't have to do it at that stage. You can just type that straight in your calculator. You should have x is equal to 1.55 or x is equal to negative 0.8. And these are the roots of the equation. And just to see what this would look like on a graph, here you have your first root, which is negative 0.8, and your second root, which is 1.55. So well done if you got that correct, especially with those negatives. Now, I would just like you to, again, pause the video, and you're just going to practice using this quadratic formula, because practice makes perfect. So you're going to solve the quadratic equations, and this time you're going to round your answers to 1 decimal place. Okay, so if you just pause the video here, and when you unpause, I will put up the answers. Okay, so here are the answers for the questions. You can just mark what you've got now. And and well done if you got most of the ones that you tried correct.